Hello, everyone, and welcome to this June edition of the Community for F# Hangouts. This is Ryan Riley, maintainer, organizer, whatnot of Community for F#, and today we are pleased to have Riccardo Terrell. Riccardo will be speaking on building a FastWeb with F# and SignalR. Riccardo is a software architect at Microsoft who is passionate about functional programming. He is active in the F# community and started the DC F# users group. Riccardo is a believer in polyglot programming as a mechanism in finding the right tool for the job. He likes to describe himself as a functional guy living in an imperative world. Riccardo, thank you so much for joining us today, and we look forward to seeing what you have to show us.
All right, thank you, Ryan. Thank you for coming. I'm excited to be here. Actually, I'm excited to be back, right? So, thank you for the introduction. Actually, I'm going to probably skip the slide now. So, let's see when you can see my screen. Can you see my screen now?
Not yet.
Not yet. All right. Hold on. Okay.
Looks good.
All right. That's good. All right. Very good. All right. So, yeah, as Ryan mentioned, I'm Riccardo, and today I'm here to talk about F# and SignalR for a FastWeb. So this presentation really aimed to prove how it's possible to write, web application using functional languages as in F#. And also, the reason also for this presentation is because a little while ago I had to build a web application. I decided to do and leverage, all the functionality and the future building in F# language. So this is really an experience that I had in a website that actually went live really, I want to say 3 weeks ago. I won't show the exactly website, but the idea is really show the technology that I use to build that website. So the agenda for today, I will discuss a bit why you want to use a language like F# or functional languages in the web. I will discuss about F# future that I use to build web application, and then I will discuss about the combination of technologies such as SignalR, F# with Reactive Extension, and also leverages patterns such as CQRS in your web application. And of course, we're going to jump in a code sample. I like to try to keep the slides on 30 minutes top, and then move in a demo and review the code altogether. So, well, Ryan already mentioned about me, so I just move on. So this is the goal of the talk. I will cover a lot of material today, but really what is important is really F# is a great language for web application, and there's also a built-in feature that you can leverage and to build fast. And when I mean fast, it's not just performance-wise, but also productivity, right? You can build easily and fast application. And what I learned in my experience during the process is that the combination of Reactive Extension, SignalR, and CQRS really beautiful technology that to me meant to stay together, and I will show that. So functional programming has this reputation about to be a great tool to express complex algorithms, right? Is a great tool to run in the back end, crunch number, analyze data. And this is a common misconception. This means it's true, but it's not just that. It's not just a great computation engine, right? F# is a general purpose language, and therefore can really be used in our daily task, right? It's not, I will talk about web application, but can be used in any sort of client application such as WPS, WinForm, and so on. And one great benefit of F# is that it lives really in a .NET ecosystem, and so really you can access a very rich set of libraries. And of course, don't forget that the main reason really is that the statement, the mission statement of Sharp is a solve complex problem with a simple code. And web application more and more these days become more complex. And hopefully, there are technology like Sharp that can really help, right? And I hope you see that I put the logo of F# like this. It's super. And F# is a great tool to solve these complex web application, right? That are getting more common these days, right? The idea to build an application is changed in the last year, and really this is evolution. It's not anymore like a static page or just a win form that you submit some information, but really you have to analyze data in real time and provide feedback in real time to our user, right? To provide also a very nice user-friendly experience. And F# is, as I mentioned, great features built in, but with that, sometimes it feels like a black box. Sometimes it feels like magic. And when something that special and that magical need to be mastered, you really have to know how does it work, right? Well, it's not really necessary. Like I like the example about the garbage collector in .NET. Everybody knows more or less that the garbage collector, how it works, meaning work in the back end, and kick in when something needs to be cleaned up for you, some resources. And this is just kind of magical, right? It just works for you. So really, do you really need to know how the garbage collector works to run an application, to build an application? Well, probably you don't, right? But it definitely helps to know better how this functionality works, right? So you start to feel that you know how to apply best practice and design pattern in something that also feel magical, like the garbage collector or the F# features built in. So I will try to go fast here because I believe that majority of you already know these technologies. But I just want to summarize and introduce what I use for the web application that we demonstrate later on. So type providers, briefly, really this extension, right, for the compiler, right, is I call it intelligent for data because it really provide integration for external data sources and a compile time and allow you to access these types lazily, right? So these are lazily provided for you, these types. And really, there are type providers such as, out of the box, the JSON or the service type provider or data access type provider that are very useful when you build web application, right, to parse income messages. But as you see the last line, you can write your own, right, and leverage this technology to solve your problems. So really, this is the classic example, right? You can just download by using the Nugget package and the type provider. In this case, it's the Excel type provider. And really, what it does allows you to specify, the file, the Excel file, and the compile time. You can access the types of this file, and also if Sharp is smart enough, is able to provide the type, right? Like for instance, in this case, the tweet ID, he knows it's an integer, right? Or the first one that first row is create date is a date time, right? And if you try to access this type against the primitive, right, you get an exception. So this is how you really bend the technology to your need and leverage the feature that F# has to really resolve complex problems. Function composition. This is one of the tenets of functional programming is the fact that you really can compose function. And never as before, when I was building the web application, I really found this very useful, right? Especially when you have like this is in a slide MVC controller. When you receive your income request, you have to validate the income request and also provide some sort of message to the user if something can go wrong, because unfortunately, something can go wrong, and you have to analyze the message, and also it's hard to analyze all the possible validation, right? And they start to be very complex path of branches, so it's like the unhappy path, right? So one of the big benefits of functional programming is really the ability to breaking apart all these branches in a smaller and more generic function. And what it provides really is the fact that you can test this single function and compose them and sweeping around. So in this case, this is a simple example using pattern matching F#. You can see how you start to branch in and validate your type, and can be a bit more cumbersome, but this is only 3 steps, so it's really nothing super complex. But I think that everybody in a career wrote something like this slide here, right, with a lot of if statement, do this, do that. So this definitely is not a great approach. So functional programming can help composing and decomposing this function together. So in this slide, this is like the ROP, which is the Rails way oriented programming. It starts to be one of the best practice, in functional programming. And sometimes it can be a bit overhead, a small portion of your code. But overall, I found out that actually is it's nice when you create your little framework and help you to decompose the function in a very more declarative style. So really, we create our type, and then we're able to bind this type, the result of the type, with a bind function, right? Because we know that the result of one function matches the signature as argument the following function. So we can really compose the function together. You can see in the right corner of the slide, and still more declarative. And at this point, I can test the single function. I can move it around, and definitely is way better than with the very cumbersome list of branches altogether. So this is the Rails-oriented programming. The link here is a great blog, and what is very interesting at the end of the blog actually explain how you can leverage this pattern also from C# and other .NET languages. So check it out. One other technology that I use in a web application is the agent built in the F#. And the idea of the agent is composed of 3 parts, right? We have a mailbox, which is just the queue of messages, a behavior, and a state. And the agent really a unit computation that you can send messages to be computed. And while the agent is single-threaded per nature, it's still no blocking throughout the world. So when you send the messages, it's no blocking. And because it's single-threaded, is also thread-safe per nature. So the messages are passed by values, so they're immutable. But also, they are isolated inside the mailbox, and nobody externally, no other agent or other piece of code can access the state. And definitely, F# shine in the distributed computing and using the agent and async workflow, and provide scalability out of the box, which is very important for web application. So, yeah, as I mentioned, agent is independent computational entity. And as I mentioned, the messages are immutable. Well, functional programming, the type function programming are immutable as default, but really with the agent, because I pass it by value, this is more emphasized. And of course, they are isolated. Briefly, this is how you implement an agent in F#. We will jump in a code sample later. But it just, you can see the third line is asynchronously no blocking, waiting to receive a message. And when the message received, I use pattern matching to deconstruct the message and then compute it accordingly. So FastScript, this is a very light framework, very light library actually, a very light F# library that really allowed you to easily develop a single page application in F#, but it's run as JavaScript, right? So the great thing about FastScript is that it's very light, but also you can you use and leverage all the F# functionality in a code and be translated for you in JavaScript. So you can even connect, external services. You can use the async workflow, and you can see here in the slide, you can access to the data structure and also list comprehension. And really, it's so easy that you just, you can access the element in your DOM. Just you can see in the slide using the get element by ID. But really, FastScript is a sort of type provider built on top of TypeScript, so you can access all the library that TypeScript can use. So you can use jQuery, Knockout, Node.js. You can build all these functionality leveraging the F# statically typed language like F#. So again, you can access all the full list of data structure in F# from the record, the tuple, and so on. And also, you can see the last line, you can access all the .NET library, and that will be taken care of for you and converted in JavaScript. And this slide is interesting. I just highlight how you can write code in F# and using Reactive Extension, for instance, or in this case also the async workflow. And again, this is going to be all converted for you in JavaScript. And again, as I mentioned in the beginning, F# is fully integrated, with the MVC Web API framework. Really, Web API is pretty sure you heard about it or you just use it, but is a framework building used to build HTTP services. That really, what is great about the Web API that can be consumed from a broad range of clients, including browser, mobiles, and so on. And F# is full integration with the MVC Web API. So you can just, there's template online built by F# community, but integrate in Visual Studio, and you just select the project and create for you a basic template to start to build an MVC application using F#. One other great technology that I use during the development of the web application is the Reactive Extension, right? And really, the Reactive Extension is also like the dual or enumerable, right? So we're all familiar with the enumerable, and we have this model about pulling data, right? We're asking for data, give me something, give me something. And a Reactive Extension really switch the mindset, switch the arrow of the enumerable. So instead to pulling and asking for data, you just wait asynchronously to receive an event notification that there are some data to compute, right? And you can see here the dual. When I say dual, if you're not familiar with the term, it's just dual infer the fact that if you know something, most likely you know also something else, which is the opposite, right? So Reactive Extension really reverse the arrow from the enumerable type. So, and really Reactive Extension become very important and also be introduced in .NET starting from 4.0. So, and again, is used to build this asynchronous web-based programming using this link-style query operator approach. And to use Reactive Extension, usually you have to use these interfaces, the iObserver and iObservable. And this really provides some sort of generalized mechanism for push-based notification, right? So is the classic, it's not a classic, it's almost the observer design pattern. And F# has this concept also known as object expression that allow to create on-the-fly anonymous types based upon well-known type, right? So we can create on the fly observable type, just implement the interface signature, which is pretty useful also for testing, unit testing, when you have to mock some object. So subject is part of the Reactive Extension, is a class, is a type in a part of the framework that I found myself very useful during the development application. And the concept that is built in already the implementation of the observer and observable together, which in the beginning didn't make much sense to me, why you want to integrate the two interfaces together. But it's turned out actually that it's very useful, because you can subscribe as many observer as you want to your subject type, and just use the observer API to dispatch all the notification to all the subscribes, which is really nice. So this is a subject in action. This is actually a very simple implementation, but you can see you create your subject type, in this case just as an integer, as a income type from the event notification. And then you can just use your observable API. You can do some filters, some mapping, and you subscribe. You can see here the computation for your when you receive the event. And you can have multiple subscribe, and then you just use the observer API to dispatch all the notification to all the subscribes. If you think about it, the subject is really it's all about sequence of event and messages, which remind me a lot like the a bus, right? Some sort of publisher subscriber pattern. And in F# it can be very useful when you leverage the pattern matching. So you can create your discriminator union, and then subject just receive the messages, and using pattern matching, match the message type received and compute the branch accordingly. So I will show the code sample later, but this was very useful to build some sort of message pass between my front-end API to the back-end. And F# is some sort of so Reactive Extension comes in two flavors, right? F# have a small subset, have already built in the language, which has already several API useful. They most of the time cover what you need, but if you want a more rich set of API, you should download that Reactive Extension package, right? One interesting thing is this man, Eric Meyer, which is the mind behind Reactive Extension, in 2009, I think, yeah, 2009. Oh yeah, I put the link actually in the bottom of the slide. In 2009, during a podcast on Channel 9, in the end of the podcast, he really mentioned that F# was an inspiration for him for the Reactive Extension. So kudos to F#. All right, so this was the review of technology that I used to build the web application. So I leveraged the type providers, the agent, Reactive Extension, and FunScript, and so on. So let's bring us to the second part, technology that I use beside F#. And SignalR, if you're not familiar, it really is, to me, is an amazing framework that is able to deliver real-time and bi-directional communication between the server and the client. Really is a message platform, right? It provides real-time data that is able to send and notify the back end and the front end. So SignalR handle the connection automatically, and it likes really to broadcast the messages to the caller, to a group, and or broadcast to all the subscribed to the hub. And the classic example that SignalR is used, for instance, the chat, where you can send a message to a single user, but also create your chat room and send a message to the group, right? And the idea really, when SignalR established the connection is persistent between the client and the server. And unlike the classic HTTP request connection, which is reestablished each time, right? So really, SignalR is I call the new kids on the block. Is a very cool server-side software designed really with the scalability in mind, right? Is really allowed to write scalable internet application. So SignalR really include out-the-box asset of transport, and when the connection is established, use techniques underneath it, all transparent to you, to create this underlying connection and keep it open between the server and the client. And it determines, is able to determine which kind of protocol to use, starting from the best one, and then fall back until found the protocol that both the client and the server agree to communicate. And of course, SignalR try always to select the best and the more efficient transport, right? And then fall back, of course, to the less efficient one. And again, all this negotiation between the selection for the protocol between the client and servers is done underneath it, and is able to also handle when the connection drop, right? So if connection drop, when it's able to send notification if you register, otherwise reestablish the connection as soon as is able. One of the things that I want to point out here is OWIN. SignalR can be hosted in OWIN, and so you can leverage the idea of OWIN to host SignalR in a cross-platform. Can be hosted, in the Mac OS, Linux box, and so on. So what SignalR can do? Well, anything that really needs some sort of real-time functionality, right? You really use anything that need an update in real time. It can be anything generic or sometimes more specific, like stock ticker or live score, right? And I put there the link that Internet Games, and you should check it out how the game has been built, and you can really play with your coworkers, your friends in real time, and how the user experience is great, right? It's a sort of well, Internet Game is a collaborative application, and everything is collaborative. Definitely, SignalR can be leveraged for this sort of application. So SignalR have a few level abstraction built on top of the connection. One is the persistent connection, which is more low level, low to the metal. And really, the experience on programming using the persistent connection, really some sort of programming against socket, right? You send and receive raw data, and you are responsible to serialize, deserialize this data, and also validate this data. And versus the hub is more user-friendly, sort of provide more user-friendly API, and most likely hubs is what you will need 90% of the time in your application. So briefly, to provide an idea, so we have the left side JavaScript client side, and the purple one on the right side is F#. You can see there is this communication between client and server that is done really with the start, send, and receive, and match the on connect or receive in the server side. Versus a more friendly use, the hubs that really able to match one-to-one the function that are in the server and the client. So you can see here, if you have a function in the server side called message that send a text, you can access this message function in JavaScript directly with the same semantic notation. And also the notify, the server side can access the notify JavaScript function from the server side just as a semantic notification. Now, there is some caveat though. So this is it's very efficient, but the problem is that in the server side, client side JavaScript is some sort of dynamic. So, server side, you cannot really access the JavaScript directly from F#, right? Because F# is a very strongly type. Like in C# is a bit easier because there is the dynamic keyword, the dynamic type, so you can leverage that. In F# you cannot. So there are other issues that come along with this kind of pattern. That typing is very important. If you mistype something in a client server, SignalR stop working. So you have to be careful about the typing. If you change something in a client, you have to reflect the server side and so on. So as I mentioned, really you cannot access dynamic type in F# like in C#. So if you really try to match the function in JavaScript, you get a squiggly compile exception and tell you no, you cannot do this. So in F# you can use the question mark operator, which actually is a fixed operator. You have to create your own. You need to leverage some sort of reflection back and build yourself, which is okay. But there are better tricks that actually was introduced with SignalR 2.0. And the idea is that you can abstract and actually extract an interface server side and match the functionality in the client side. And then you're able to use this interface when you create your hub, and then you can statically type access the functionality from the server side that match the functionality in a JavaScript in the client side. Well, this is sort of okay, but there is still a problem, right? I mean, we still extract the interface in the server side, but still the interface need to match my client side JavaScript access to the server side function. So yeah, we statically type in the server side, but still we have to be careful that we change something in the client side, need to match on the server side, and vice versa. So there is still some problem, right? So a better solution, well, as I mentioned, we can create our own custom type provider, right? In this case, SignalR type provider. And what we can do right now is that in combination with FastScript, we can build our application using F# and access type provider SignalR that is able a compile time to access also the server side functionality statically. And if you try, as you see in the slide here, if you try to pass an integer with expecting a string, you got a compile exception. That's a compile application, which, as you know, in JavaScript, this is pretty common, right? So definitely, SignalR, type provider SignalR is a great solution for this problem. So I talk a little about Reactive Extension, and I talk about a little bit SignalR, right? So there is the link here about this book about introduction of Reactive Extension online. And when I was reading this book, I found it very interesting that when you read the section where it is recommended to use Reactive Extension, you can see the red arrow. It said that it's great to be integrated in events like broadcast from messages bus or push event from WebSocket API. So really Reactive Extension and SignalR are some sort of really meant to work together, right? This is a code server side. This is SignalR server side, which is nothing fancy, but just to give you an idea how the fourth line from the top, when you get your data from the server, you just be able to transform it as observable. And now you can just ping and broadcast all your data using the Reactive Extension to all the subscribe to the SignalR. It can be more sophisticated, like again, you can even receive data like a stock ticker and group by the event that you receive notification by the symbol. And then you have a stream of streams, and then you can analyze the single stream individually. And this is a Reactive Extension using client side and a SignalR Reactive Extension using client side. So this is a WinForm application, but again, it can be used in the WPF console, or as we will see from FastScript, right? So now you can open the connection, connect to SignalR, and now awaiting asynchronously all the stream and event the SignalR server side is going to send you, and use observable link style semantic to analyze your incoming event. CQRS. CQRS pattern is Command Query Responsibility Segregation. Is a pattern that is used really to separate the read and the write in your application. I found it very useful in a web application for the separation concern, but also able to separate maybe your team to work in different parts of your project and separate the read and the write. Now, Command Query Responsibility Segregation introduced several benefits. It's easy to understand the reason about what application does. And it also is testable, of course, but also resolve the problem of scalability, right? Because you can see that the right side is one cylinder, but in reality, there could be two databases, right? One for the writes and one for the reads, which is in the classic end-tier web application, the bottleneck is the one database, the one big monolithic relational database that we have in the back that is really the bottleneck for our application. Here, you're able to separate the query and the read and the writes, and the two storage in the back can synchronize and each other. So this is, again, introduced several benefits in CQRS, right? And almost infinite scalability, which is ultimately the goal to create and build fast web application. Clear understanding of what the application does, and maintainability. Now, with all these great benefits, there are also some, some price to pay. And the problem is that when you send the data, actually, there is some sort of delay, and the read and the write, they're out of sync, and they need some time to synchronize, right? So how you're able to reflect in your UI, right? This is an eventual consistency that if you send some command, most likely your UI won't reflect the real write side right away. So there is some delay. So how we can solve this problem, right? We can refresh the page, we can fake it, we can use a confirmation screen, but how about use SignalR, right? So at this point, you send the write to CQRS to push the write to your backend, and that's it. And then when the synchronization happens and the read part is synchronized, it notifies the UI, it notifies my client with update and no stale data anymore through SignalR. So really use the real-time functionality and leverage for provide a better user experience. So if you remember our first slide, really we remove even the need to query our read side. We send the write and we just wait to receive back the updated data. So in the beginning, I was looking for something to able to for this presentation to able to use all this technology together. This is, I put the link here, is the SignalR stock ticker that Microsoft actually provide as an example. It's written, it's right, of course, in C#. In the beginning, I converted in C# to F#. As you can see, really, the reduce of line of code required, right? Because just no translation language to language is not semantic issue, but really apply a new paradigm. But I wasn't happy, so as a good engineer, I tried to complicate the project, and this is ultimately the high-level architecture or the project that I will show, right? So briefly, I have my web API front end. I have all the front end is use FunScript, so there is no line of JavaScript or C# in this code. It's all F# or HTML. So the web API send up, they receive the notification from the front end, go through some validation, and publish the command to my stock market. And the stock market, as you can imagine, is responsible to open, close the market, and keep updating the ticker, right, with a new value. We have a stock ticker hub that is registered when the new user open a connection, create a connection, and create some sort of agent in the back. And the agent, it keeps some state, which is the state of the user in some sort of portfolio, right? So the user now is able to check the market and also submit some order to buy and to sell. Now, the great part is here that you can submit an order to buy, and the agent will wait until receive a notification that the price of that ticker received the price that was indicated in your order. If that's happened, it's gonna submit the order and notify and update my UI. So let's see this demo in action. All right, let's run it first, and then we're gonna go through the code sample. Okay, so now the stock ticker up, and you see I load my stock, part of my portfolio, and the asset here start is $1,000, right? So I can start my stock ticker, and now the stock ticker in the back update my SignalR hub and real-time notify the update of my UI. So now I can, submit some order. Let's say that I want to buy some stock, right? So in this case, I want to buy, I don't know, some Microsoft, and the price I want to buy for 41.95, and let's buy 10, right? So when I click buy, the order go through. It is an order to buy, and then when the order reached the level, it's submitted. So you can see that was fairly quick, but for a little bit was in the state of buy to order, right? Now the order went through, and my agent submit my order and notify through SignalR and update my updated asset, right? So you can see my cash now is $580 because I bought 10 stock of Microsoft, and now, of course, I can sell it, right? So I can sell Microsoft, and I can sell it for 42 because we make some profit. And now, when I submit, now the order to sell is here in state, and wait until it reaches the 42. And when it reaches the 42, now the order is submitted, right? So the notification went through the state of my agent, and the agent said, okay, I received stock from Microsoft. There is 42 or more. Should I buy it? Well, yes, I have an order here. They want to sell it for 42. Sorry, I say buy. Sell it for 42 and provide and submit the order and notify my UI. So you can see here, I already done 60 cents. So this is pretty much how this is work, which is great that you think whole the functionality of what happened underneath it, right? So let's buy something else. So let's buy Apple. I want to buy for 92, 98 because Apple usually is strong. Let's only buy 5. Oh, okay, that was super quick. So it was already past the limit. So by the time, let's sell it. Let's say Apple again. Let's make some money, right? Let's buy it. Let's sell it for a little bit more. Now it's there waiting. It went through. So as you can see, in a few minutes, I already make $1.35. I can keep going, all day and becoming very rich. So this is a prototype to make money, and definitely is how this is working in the back is very interesting. So let's check the code sample. So the code. So As I mentioned, everything is built using F#. Is a using the template, Web API template. The front end use some HTML, of course. I use in this case Reactive.js, which is one of the many JavaScript library to update create some sort of binding, like probably more familiar with Knockout. We just updated the UI if something changed in my model. So in this case, I have stock. If it's changed the value or the size of the stock, we put it in my HTML. This is some templates. So this is the threaded controller, which is my web API. So you can see here, I use a subject from the Reactive Extension passing the command wrapper. And the idea here is really leverage the Reactive Extension and decouple, the controller, right? So the controller is not anymore tied to anything, just it works as a subscriber, right? So now what it does, the controller is just responsible to send out notification to its subscribe, but it really doesn't need to know who is subscribed, right? So this is great also for unit testing. This is the post cell action, and in this case, I just receive a trading request. You can see here I get the connection ID. So when SignalR establishes the connection, it creates a unique identifier that is specific for the connection, and it can be used really to differentiate different connections. I create my trading command and just pass the symbol of my order, the quantity, the price, and if it's to sell or to buy. And here I just use the F# pipeline operator just to connect in pipeline as a flow different functionality, right? In this case, I have some validation, some logging. I publish my command, and I return back the response. So yeah, the trading records I mentioned, symbol, quantity, price, and trading. I use the ROP approach to validate the income request using function composition. And when I publish the command, you can see here I use the Reactive Extension really use the subject of next API just to push out the command wrapper command to all the subscriber. Now the command wrapper is just a wrapper around my command, which is a good practice in CQRS or in general to wrap your message inside the wrapper to inject some extra metadata, like an extra a unique identifier that it might be used in the backend to aggregate the messages that relate each other. In this case, I won't use that functionality, but like it can be used to use some sort of saga, right? And of course, some timestamp and so on. Log and to response is just pattern match against the result of the previous function is a success or failure, and then proceed accordingly. The startup is where you create and you set all your configuration for the application, some sort of global EX if you're familiar with the ASP application, right? So you can determine your HTTP route for the routing, and just the configuration, just standard, configuration for your application, set your serializer and your HTTP routing and so on. Part of the configuration when you register your SignalR hub, and what it does, it really scans through all the DLL of the project and detect all the types that are marked with the attribute hub and register to be a SignalR. In this case, I use a simple functionality and allow all course call, but you can even customize the URL and so on. Now, as I mentioned, the controller is decouple, implement the interface observable, it become observable. So it's complete decouple from all the Web API framework. But I need to register some observer, right? So in this case, I create my own HTTP controller activator, and I pass in a constructor an observer. In this case, I use only one observer, but in reality, you can have several observers can register to the subscriber. So what it does, it check, and when the request need a trading controller, my framework detect that and treat the controller as an observable and register my observer, the pass in the constructor. And a part of my configuration, I just replace the custom controller activator with my, the default controller activator with the custom one that I built. And you can see here in the constructor, I pass observer.create, which is part of the Reactive Extension API. And what it does, allow me to create easily an observer. In this case, I just pass an agent post because, as you can imagine, I'm going to send a message to a local agent, right, that is able to buffer all the messages asynchronously and compute asynchronously. So in this case, I receive the message, and I use the pipe operator to handle this message asynchronously. And the async handle function is just asynchronous, and use a computation expression to send the command. It just retry publish, just hide underneath it a lot of more complex code, right? Just but what it really does is just send the command. If something goes wrong, it delay a little bit and retry until the command is sent successfully. So the server side, we have the stock ticker SignalR server. And we start with the hub, with the stock ticker hub client interface, which represent all the functionality that will match JavaScript, the client side, right? Now, in the hub, I have two static type, user count and stock market, and they need to be static because the hub is recreated every time a new connection is established, right? If you don't use static type, you're going to lose your state. Now, remember the stock ticker name here. So I will show you what we can do later with the SignalR type provider. Again, we have some functionality, the onConnect, which receive, this is a fire up when the new connection is established, and send a subscribed command to my stock market, which register my client to my agent. And disconnect, of course, unsubscribe, and remove the connection. Now I have some extra functionality to get all the stocks, open the market, close the market, and all the stock just broadcast to the register, the stock part of the portfolio. The stock market, as you can imagine, it just keep track of the ticker and update the value. I just use a very sophisticated algorithm, right? I just use a timestamp, an observable interval that every 85 milliseconds push out to my local agent to update the stock prices, and then the agent just broadcast to all the subscribers, which are agents, the new value of the updated stock. So the stock ticker market is an agent with two states. Mark is open and mark is closed. So as you can imagine, the market stock is in closed state, right? And both state is open and is closed. They keep some sort of state, which is the stock that are part of my market, right? So if I add a new stock, just going to be added to my state recursively in a function. This is the type of the stock, which is pretty simple, symbol, the open, low, the low price, and the last change, with some functionality to calculate the percentage of change. So the first state, when it's closed, the agent, which is my market, just wait asynchronously to receive a message and compute the message, right? In this case, it's able to open the market, get all the stock, or change the state of the market. And when it changes the state of the market, it starts with a new state, which is the market is open. So the second state, the primary functionality here really is able now to send out a notification when the stocks are updated, right? So when receive the message to update the stock, it just broadcasts to the agent that the new value of the stock, and then the agent individually, asynchronously, can be in process, out the process, or across the network, can access. That means can receive the message and compute asynchronously, and really able to render the application more scalable, right? So the trading supervisor agent, really what it does here is just some sort of middle tier to keep track of all the agent they subscribe. What I want to point out here is that when the agent subscribe, the agent is really an observer, right? So it registered to my subject, so I create a trading agent, and then I subscribe the agent to my current subject, and then able to the agent is able to notify all the observer using the same API as the observer. And here, the return loop here, I just keep track and add a new observer in the collection and keep track of the new observer. This is how I expose the API. You can see at the bottom here, because implement the observable interface, I can treat this agent as an observable and subscribe observer that are my trading agent. In this case, my trading agent are really what represent is the user, right? My client that open the browser, create a connection, maybe log in or something, and create an agent that represent my user and keep track of the state. In this case, I have some type here in agent, my portfolio, my buy orders, and my sell order, which are just type alias that represent just a simple dictionary with a string as the symbol of the stock, and a collection of trading details, which is the trading operation, buy, sell, and the quantity and the price of the stock. So functionality to buy, sell, just receive the command, process the command, update the current state, because now in case the buy gonna change the buy orders state, and the same for sell. But the most important one is the update stock. And what it does when they receive this message, it check the agent, it check the current portfolio. And if there is any stock or any order to buy or to sell with that symbol, well, it's gonna take some action, analyze the current price of the new updated stock with the stock in my order. If this match, we're gonna process the order. First, we're gonna start with a sell, because most likely, if you sell something, you have more money to buy. And then, of course, the buy process. And when everything is completed, we're gonna send out notification with the updated state of the portfolio to my front end. So now the last part is the stock ticker client, which is I use FastScript to build my single page application. And as you can see here, I can alias some extra libraries, such as the second one is in the second box, use J to alias the global dollar invoke, which is jQuery. And I create the instance of my stock ticker hub that is, I use, in this case, the SignalR type provider that access my server-side stock ticker. So now I'm able to access statically type my server-side functionality from the client side. Now, the type, when you use SignalR provider, they're kind of cumbersome, but you can type alias, so the order record is a bit easier to read versus the SignalR provider top types and so on. I create something.
Riccardo?
Yeah.
Real quick question: Are you saying there that you can actually check the client and server implementations against one another, or was that, did I mishear what you said?
No, that's correct. And actually, in 2 seconds, I'm going to show you exactly how this works. So the async post JSON one way is just prove how you can use async workflow in FastScript, and they're going to be converting for you in JavaScript. You can see actually pretty interesting. You can use the global JSON stringify to really serialize your string, right, in JSON format. On start is the function that but call first the server hub, which is my SignalR hub, get all the stock and update my UI, and this is I use jQuery, the stock ticker, to start the scroller, right? Here the init function is just function for some setting for reactive.js, which I say reactive.js, but I don't use JavaScript. It's just a library that it can be used from FastScript side. You can see here the stock ticker. Actually, the next slide. Yes, I create some collection here. The stock, the asset by order, they actually match exactly the HTML side, right? So when FastScript access this collection and change something, the data binding kick in and update my UI, right? How I register some event here? I register open, close, and buy stock, which really are the ID or the button of in my page, right? So when I click the open, well, the first event is fire up, and I wait asynchronously. And when this event is fire up, I just use pattern matching and compute some functionality. In this case, I open the market and use jQuery to disable or enable the button UI. Another approach, you can use Reactive Extension to register your event, just to prove a different approach, how flexible is the library. You register your event here, and then in this case, I use jQuery to get information from my text box, create my command, and send out using the JSON post asynchronous function to my Web API controller. And this is the main function, which is the function where you register the URL of the SignalR. And here, the fourth line, you have access to the stock ticker hub client, which is the interface that you create in the server side. So at this point, the interface server side match the interface in the client side. So you cannot make any mistake. In statically type, typos are impossible because you can leverage IntelliSense, but at the same time, you get the compile time error if something goes wrong, right? And here, just simple functionality, update, order by, and so on. Last part, I just convert all the file using a FastScript functionality in using code quotation, and create for me a JavaScript file. Now, I want to show something here. So this is still running, right? But what is great here is, Ryan, you mentioned, let's say that I'm server side. So let's close the server, stock ticker. I think one of the other both work. Okay. So let's go to the stock ticker hub here. So stock ticker hub has this stock ticker name as a string, right, which represents really the name of the hub that need to be accessed from the client side. So you can see here, stock ticker match the specific name, right? So if I and I have access to IntelliSense, right? When I click, I access to the interface or the hub per se. Now, if I change something in the hub, let's say I change the name, right? Well, now I get the problem because now if I try to compile it, I'm going to get a bunch of exception because now my client side doesn't know anything about the stock ticker. What it does know is about stock ticker 2, right? Which is pretty cool now because you can see now you cannot mess, right? If you change something in the server side, I need to match on the client side and vice versa. And also, if you try to access, try to call a function client side that require an integer, but actually server side is a string, you get an exception. Does that answer your question, Ryan?
That does. That's quite nice.
Yeah. So, and I usually extract my, I create an external library console app to use FunScript. They actually use the wrapper, generate the script really as a JavaScript file, and then push and save it to my web app. There are many different approaches. You can actually embed it in your web app and update it every time you make changes. But I think this is more flexible to me. And so let's run it one more time. I want to just let's do something crazy here. Let's open the market. So I open the market in one side, but they both start. Now, if I buy the stock here, Microsoft, I want to buy the price, 42.96.5. I buy the order from one side. The other side, different agent, different client. I can buy Apple price 92.99. I want to buy on 5. So you can see they're two totally independent units, right? So this is pretty cool. All the slides and the code are on GitHub, and actually, I want to just open the question. Just to summarize again, F#, I think a great tool for develop web application, and I hope I convey this message. And but really, I think that Reactive Extension, SignalR, and CQRS really great technology to build together and to use together, and also with the help of type provider, custom type provider, hopefully you're gonna bend all this technology to your will and solve some complex problem. So this is my information. Actually, I changed here, but you can go to my GitHub account, download all the slides and the code sample. This is my Twitter account, my personal email if you have any question, but otherwise, I'm here, and that's all I got. Ryan, I know you have a question.
Yes, and if anyone else has questions, please feel free to add those to the Q&A section. Riccardo asked one of them already, which was knowing or being able to share types on the client server, which you just showed, so thank you for that. The second one was SignalR doesn't make any guarantees on message delivery to clients. Have you found that to be a problem in any case, or have you found any good fallbacks or countermeasures to make sure that the client can always get the information it needs in some way?
Yes, well, depend, right? In this case, no. The application that I built, I did build something similar. But even this application with a stock ticker, think about you send a command to the server, which is going to some sort of, in this case, in memory, but keep some state in an agent, right? Now, if the connection drops, SignalR is smart enough to reestablish for you. But in this case, I can submit my order to buy, close the browser, go in the bed, and because the command that persists in my agent that keep track of my state is still able to compute the order when the stock ticker reaches the price that I put in the order, right? And then I wake up, just check my order, and I'm rich, right? So really, it's up to you to build some sort of persistent layer. There is nothing really out of the box. There is a functionality called backplan in SignalR. This is actually, the idea is to scaling out your SignalR, right? But in case of distributed system that you can use backplan, actually you can use as a caching, but also as a persistent layer to keep track of your messages and guarantee the delivery. Does that answer your question?
It does. That's great. Thank you so much. I don't see any additional questions in the Q&A.
I answer one question myself that I get one other time that I do presentation. So about performance, SignalR, usually IIS, SignalR can be hosted in IIS or not. But if you like hosted in IIS, the default is like 5,000 connection, I think, 4.0. I don't want to increase that. But you can, SignalR, you can change the setting, and ISO application, you can have like over 45,000 persistent connection without any problem. And another question I get all the time, the size of the message. Don't send, a file. Message should be common sense small, like the recommended top 32K. But like if you want to download a file, probably use SignalR to send out, the URL, the path to download the file, and manage also the real-time update by using a different channel to upload or download the file. And that's all.
That's excellent.
Okay.
Thank you so much, Riccardo. We'll be happy to have you back anytime. And if anyone listening has any suggestions, requests, or would like to present on Community for F#, we would absolutely love to have you, or love to have any recommendations or suggestions that you have. The best way to reach out is to either hit us on Twitter at C4F#, FSHARP. You can also reach us on GitHub. There's a C4F# organization, and you can ping any one of those repos and submit issues or whatnot. Again, thanks, Riccardo. I know you're working on some additional material, so we may see you again on here soon.
Yep.
This has been recorded, and we'll be posting this very soon on YouTube. So again, thanks everyone for joining us, and have an outstanding day.
Bye, everybody.